Download this code from codegive.com, link in the description below. Hibernate tip: effective cache invalidation for native queries. Hibernate's caching mechanisms are crucial for improving application performance by reducing database load. However, when you're dealing with native queries, SQL directly written by you, maintaining cache consistency becomes a more challenging but essential task. If you don't properly manage cache invalidation for native queries, you risk serving stale data to your users, leading to incorrect application behavior. This tutorial provides a comprehensive guide on how to effectively control cache invalidation when using native queries with Hibernate, covering various scenarios, best practices, and code examples. 1. Understanding the caching levels and native queries. Before diving into the solution, let's recap the key concepts. Hibernate's caching levels. First level cache, session level cache associated with each session. Data retrieved within the same session is cached. This cache is automatically managed and is usually not a concern for cache invalidation. Second level cache, session factory level cache shared across all sessions created by the same session factory. This is where cache invalidation becomes crucial. Hibernate offers pluggable cache providers like Ecake, Hazelcast, Infinispan, etc. Native queries. Raw SQL queries that you execute directly against the database. Hibernate executes these queries without automatically knowing their impact on managed entities. This is the main reason why manual intervention is often required for cache invalidation. Why cache invalidation matters for native queries. Imagine a scenario. 1. You have a product entity stored in your database. 2. Hibernate's second level cache contains a cached copy of a product with ID equals 1. 3. You execute a native query that updates the price of the product with ID equals 1 directly in the database, bypassing Hibernate's entity management system. 4. If you subsequently retrieve the product with ID equals 1 through Hibernate, example using session.get, product.class, 1, you'll get the stale data from the second level cache, not the updated price from the database. This is where effective cache invalidation strategies become indispensable. 2. Strategies for cache invalidation with native queries. There are several approaches to handle cache invalidation for native queries. Choosing the right one depends on the complexity of your native queries and the level of consistency you require. A. Automatic invalidation, when feasible. Identifying modified entities. If your native query's impact is limited to specific entities that Hibernate manages, you can leverage session.evict, or session-factory.getCache.evict, to invalidate the corresponding cached entity instances. Explanation. 1. Entity mapping. The product class is annotated with @entity and @cacheable to enable caching. Make sure your configuration file, hibernate.cfg.xml, has property name equals hibernate.cache.use_second_level_cache true/property and property name equals hibernate.cache.region.factory_class org.hibernate.cache.ecake.ecache region factory/property, or similar for your chosen cache provider. 2. Native query. A native SQL query updates the price of a product in the database. 3. Cache invalidation. Session.get session-factory.getCache.evict, product.class, 1L, explicitly removes the cached product with ID equals 1 from the second level cache. This ensures that the next time the product is retrieved, it's fetched from the database, reflecting the changes made by the native query. 4. Verification. Retrieve the product before and after the native query to demonstrate the cache invalidation. Important considerations. Asterisk identify affected entities. Asterisk this approach only works if you precisely know which entities are modified by the native query. Asterisk granularity. Asterisk you can invalidate individual entities, evict, product.class, 1L, or entire entity regions, evict, product.class, to invalidate all product entities in the cache. Asterisk synchronization. Asterisk make sure the native query and the cache invalidation happen within the same transaction to guarantee atomicity. B. Selective cache invalidation using @cache invalidate, Hibernate Envars extension. Hibernate Envars provides a powerful auditing mechanism and also the @cache invalidate annotation to selectively invalidate parts of the cache based on changes made by any kind of query, including native. This approach is suitable for more complex scenarios where it's difficult to directly track the modified entities in your Java code. 1. Add Hibernate Envars dependency asterisk. 2. Annotate your entity and enable Envars asterisk. 3. Use @cache invalidate with native queries asterisk. Explanation asterisk. 1. Envars integration asterisk. The audited annotation enables Envars to track changes to the product entity. Ensure Envars is configured in your hibernate.cfg.xml. Example property name equals org.hibernate.envars.audit_strategy org.hibernate.envars.strategy.validity_audit strategy/property. 2. Add synchronized entity class. When you execute the native query, use query.add synchronized entity class, product.class. This tells Hibernate that the native query might affect the product entity. Envars will then use its auditing information to determine which entities, if any, were actually changed and invalidate their cache entries. Note: use add synchronized entity name, product, if the entity is accessed via its entity name rather than its class. 3. Automatic invalidation asterisk. Envars automatically handles the cache invalidation based on the audit data. You no longer need to explicitly call session.evict. Advantages asterisk. Asterisk simplified invalidation asterisk. Envars manages the invalidation based on actual changes. Asterisk reduced risk of stale data asterisk ensures cache consistency. Asterisk auditing benefit asterisk you get automatic auditing of data changes. Disadvantages asterisk. Asterisk performance overhead asterisk. Envars adds overhead for auditing and change tracking. Asterisk complexity asterisk. Envars configuration might require some initial setup. Asterisk requires understanding Envars asterisk. You need to understand how Envars tracks changes. C. Programmatic cache invalidation, using Hibernate's cache API directly. For finer-grained control and advanced scenarios, you can interact directly with Hibernate's cache API. Explanation asterisk. 1. Statistics asterisk. Get the statistics object from the session factory to track cache hits and misses. You need to enable statistics collection in your configuration. Property name equals hibernate.generate_statistics true/property. 2. Direct cache access asterisk. Use session factory.getCache.evict, product.class, 1L, to directly invalidate a specific object. You can also use evict entity region, product.class, to clear the entire entity cache region. Evict collection region, product.class.getDeclared field, products.getType.getName, to evict a particular collection. 3. Monitoring asterisk. Monitor the cache hit/miss counts to verify the effectiveness of your invalidation strategies. Advantages asterisk. Asterisk fine-grained control asterisk. Maximum control over cache invalidation. Asterisk advanced scenarios asterisk. Suitable for complex caching requirements. Disadvantages asterisk. Asterisk complexity asterisk. Requires a deep understanding of Hibernate's cache API and statistics. Asterisk maintenance overhead. Asterisk you are responsible for managing the cache manually. D. Disabling the second level cache, simplest, but least efficient. In some cases, if the native queries are too complex or unpredictable, and maintaining cache consistency becomes excessively difficult, you can consider disabling the second level cache for the affected entities or even globally. However, this is generally the least efficient solution because you lose the performance benefits of caching. Asterisk disable for a specific entity. Asterisk in your entity mapping, at cacheable, false. Asterisk disable globally. Asterisk in your hibernate.cfg.xml, property name equals hibernate.cache.use_second_level_cache false/property. 3. Best practices and considerations. Asterisk transaction management. Asterisk always perform native queries and cache invalidation operations within a single transaction to ensure consistency. Asterisk entity relationships. Asterisk when invalidating a cached entity, consider the impact on related entities and collections. You might need to invalidate them as well. Asterisk cache provider. Asterisk the specific cache invalidation mechanisms and API calls might vary slightly depending on your chosen second-level cache provider, Ecake, Hazelcast, Infinispan, etc. Refer to the documentation for your provider. Asterisk performance monitoring. Asterisk regularly monitor the cache hit/miss ratios and overall application performance to fine-tune your caching strategies. Hibernate statistics can be invaluable for this. Asterisk auditing. Asterisk if you need to track changes made by native queries, as well as other changes, consider using Hibernate envars for auditing. Envars can automatically invalidate the cache for you. Asterisk consider alternatives. Whenever possible, try to express your data manipulation logic using HQL or criteria queries instead of native SQL. Hibernate can often optimize these queries and automatically manage cache invalidation. Refactor your code if possible. Asterisk optimistic locking. While it doesn't directly solve the native query invalidation problem, consider using optimistic locking, at version, on entities manipulated by native queries. This can help detect concurrent modifications and prevent data corruption, even if the cache is momentarily stale. 4. Choosing the right approach. Asterisk simple native queries with known impact. Asterisk use explicit session.evict, to invalidate specific entities. Asterisk complex native queries affecting multiple entities. Asterisk consider Hibernate envars with @cache invalidate and synchronized entity class, for automatic invalidation based on audit data. Asterisk advanced scenarios requiring fine-grained control. Asterisk use Hibernate's cache API directly, but be prepared for increased complexity. Asterisk difficult or unpredictable impact, but low performance impact from disabling cache. Asterisk disable the second-level cache for affected entities, as a last resort. 5. Example, cache invalidation with a complex native query. Let's imagine a more complex native query that updates both product and category entities. Using envars, you could do the following. Explanation asterisk. 1. Envars integration asterisk both product and category are audited with @audited. 2. Add synchronized entity class, asterisk we tell Hibernate that the query might affect both product and category. Envars then handles the selective invalidation based on which entities were actually modified. In conclusion asterisk. Proper cache invalidation for native queries is essential for maintaining data consistency in Hibernate applications. By understanding the available strategies, automatic invalidation, Hibernate envars, direct cache API access, disabling cache, and choosing the appropriate approach based on your application's needs and the complexity of your native queries, you can effectively manage your cache and ensure that your users always see the most up-to-date information. Remember to always prioritize transaction management and thorough testing to guarantee the correctness of your caching implementation. Remember also that enabling statistics and monitoring cache hit/miss ratios will help you fine-tune your caching configuration for optimal performance.